In this video, I will show you the software compilation process. Software means program and data. A program is a series of instructions that guides a computer to do a task. This instruction means the machine language instructions. A program begins life as a high-level program source code file. For example, the .c file, .cpp file. These files, or these source code files, can be read and understood by a human being. However, in order to run the C file or the .cpp file on the computer, the individual C++ or C statement must be translated by a compiler into a sequence of low-level machine language instructions. These low-level machine language instructions are then packed as an executable file. These files reset on the secondary storage. And now, for example, we have C++ statement, z equal to x plus y. This is a C++ statement. So we have three local variables, x, y, and z. Now we want to store the sum of x and y in the variable z. This single C++ statement will be translated into 4 machine language instructions. These 4 machine language instructions. So first step, load x value to a register. And next step, load y's value to a register. And then add the value in the registers A and B, and the sum is in the register B. And then write the value of register B back to the main memory, to the variable Z. These are 4 machine language instructions translated from this Z equal to X plus Y. So here, this is an assembly instructions. Assembly instruction and the machine language instruction, they have 1-to-1 map correspondence shape. Now so I don't know the machine language instructions, but the assembly language instruction, it's easier to read for human beings. So now I use the assembly language instruction. So now for all the C++ statement, including loops, function calls, all this statement can be translated into multiple assembly language instructions. Now let's take a look at an example. Now I have a very simple C++ program. This is the main function. In the main function, we have 3 local variables. X, initial value is 0. And the Y, initial value is 1. And Z, the initial value is 0. And then we calculate Z equal to X plus Y. And then return 0. So it means exit main function. This is the last statement in this program. Now, on the in the Linux machine, assuming this program is main.cpp. This program, the C++ source code file name is main.cpp. And in the Linux For example, in the CSE Linux lab, GB359, this is a Linux lab. And then on this, in this lab, on one of the Linux machine, we use a G++ main.cpp-s. Now we use this command G++ main.cpp-s to compile this .cpp file. We can get assembling file. The assembling file name is main.s. And then we can use a cat main.s to print out the assembly instructions in this main.s in this file. And now I get this assembly instructions. Okay, now let's see this. This instruction means initialize local variable x, and this one initialize local variable y, and the next one initialize the local variable z. And then the next for statement, this for statement means x plus y, okay, z equal to x plus y. Now the first one, move. Now we know the x value is stored in this address. Now this statement, move x value to this register. EDX is a register. This the register name. Now that means we read x value to this register EDX, and then we read y's value to the register EAX, and then we add the values in these two registers. This means we add EDX value to EAX. Now in the register EAX, we have the sum of x and y. The last statement or the last instruction, we write EAX value back to main memory. Now this is the address of local variable z. That means we write this sum to z. Now this is we translate one C++ statement into 4 assembly instruction or the machine language instructions. Okay, now this image shows us the program compilation process. So now we have main.c. This is a high-level C program file. The extension name is .c. And then the next step, the compiler compile this program, and we get an object file. So here we add since this is a C program, we can use a GCC to compile this program. And then we add the option -c. Now the compiler will generate object file. The object file extension name is .o. This compiler. And then we have the object file, and we type the command gcc-o and main.o. So this means now we will generate an executable file. The executable file name is main. So we generate this executable file from the object file main.o. This process is called the linking phase. Now assuming main program calls printf function, and this printf function is a part of the standard C library provided by C compiler or the C++ compiler. This printf function resides in a separate pre-compiled object file called printf.o. The linker, this software will merge printf.o and main.o. So the result of the linker is an executable object file, or we say the executable file. Now if we don't add -o main, we will have the default executable file name a.out. And now we assign the executable file name main, so we get the executable file main. And then we have the loading process, the last phase. The last phase, we have the executable file main on the secondary storage on our hard disk. And now we want to run this, or we want to execute this program, this executable program. So we type ./main. We type ./main. This command will load the executable file main into main memory. And now we see this program, this executable file run on the CPU. And now we will link all these components together. CPU, main memory, and this executable file. We link all this together to see what happens when a program runs on CPU. Okay, I will go back to the previous page. Now we have this program, or we have these instructions. We have these instructions stored in the main memory. So when we type the command ./main, these instructions, machine language instructions, are loaded in the main memory. And now we have, now assuming we have the address of this, okay, this is a main memory. These instructions are loaded in the main memory. And now this address, the address of this instruction is 100. And then the next one, the address is 104. And then this is a 108. And next one, the address is a 10C. These are all hexadecimal value. And now this is a 110. Now, assuming this is a address of these instructions. And now the CPU, now let's see how the CPU execute these instructions. Now in the CPU, we have control unit, and we have ALU. And we also have the register PC. And we have register instruction register. and the multiple data register. Now we have the concrete data register EDX and EAX. This is a PC, and this is the instruction register. And this is a EDX. And this is a EAX. Now, assuming the PCs, assuming at this moment, PC point to PC pointed to 100. So that means PC's value is 100. Means now the next instruction is move X to EDX to this register. Okay, and now the control unit will read the address in PC. Read PC value 100, and then the control unit fetch the statement, fetch the instruction. Fetch which instruction? Fetch the instruction stored at address 100. So fetch this instruction. Fetch this instruction to, I will use I. Fetch instruction from the main memory to fetch this instruction from main memory to the instruction register. So that means now in the instruction register, we have the instruction move X value to EDX. Now in the instruction register, we have this instruction. This instruction, we have this instruction. Now fetch is done. And now ALU will read this instruction, read instruction from instruction register, and then execute this instruction. So execute this instruction means move X from the main memory to register EDX. Now we move the X value to the register. Okay. Now at the same time, the control unit will also increment PC's value. So increment PC's value, PC will point to the next instruction. The next instruction address is 104. Now the control unit will read PC's value 104, read the instruction at this address, and then fetch this instruction from address 104. Now which instruction? This instruction address is 104. So now the control unit will fetch this instruction from main memory to the instruction register. From main memory to instruction register. Now in the instruction register, we have this move Y to EAX. Now, in the instruction register, we have this instruction. And now next step, ALU. ALU will read instruction from instruction register and then execute this instruction. Okay, now we can see this is a instruction and execution cycle, or the machine cycle. Now the control unit fetch instruction, and then ALU execute instruction, and then control unit fetch instruction, ALU execute instruction. So the CPU will execute the instruction stored at 100, stored at 104, and execute the instruction stored at 108, and then 10C. So one instruction by one instruction until we reach the end of this program, until we see the return 0. Okay, this is how the CPU execute a program, execute the machine language instructions in this program. Okay, for this video, we will stop here.